have a look at practice question set number 3 up here now. Right away. I have no idea what I'm being asked for in question number 1 or question number 2, because it does say use the following information to answer the next 2 questions. But listen, I do know that I have a force versus time graph, and I know that every time I see a force versus time graph, I always got to think of 3 words. What are they? I thought you were going to say it there. Area equals impulse. Area equals impulse. So regardless of what I'm asked for, this has got to be kept in the back of my mind or the front of my mind, somewhere in your mind here. I don't see any strange units, although I do see a times 10 to the 2 newtons. So I'm going to circle that because that could lead me to a calculation error. Sometimes what I do is when I'm calculating the area, I just use the numbers on the axis and I forget to add in the times 10 to the 2. No milliseconds or anything like that. Let's look at the question now. The area under the curve represents, all right, the area under the curve represents, this is easy, the impulse experienced by the object. We didn't have to do anything there other than recognize that area equals impulse. Question 2 says, the impulse experienced by the car from 2 to 5 seconds. Boy, you sure got to be careful about that one, right? What's the temptation if you're not paying attention in this one? Get the whole thing, right? Get the whole thing. And I would guess if you calculate the whole area, that option is going to be there. They do that as those nasty little things to us sometimes. So we got to be watching out for things like that. From 2 to 5 seconds. Well, the good news is from 2 to 5 seconds, there's only 2 shapes instead of 3 shapes. I got a rectangle and I got a triangle. We'll call this section 2. We'll call this section 3. The area of section 2 is a rectangle. It's 1/2 base times height. It goes. The base is 2. The height is 20 times 10 to the 2. Does that make sense? How many people forgot the times 10 to the 2? Nobody's owning up to it at least, but that's an easy mistake to make, and I suspect that some of you probably did. If you didn't, good. This ends up giving me 40 times 10 to the 2, or 4.0 times 10 to the 3, and the units, of course, are going to be Newton seconds. That comes right from seconds, newtons. Seconds, newtons, or Newton seconds. Sorry, that's area 2. Area 3 is 1/2 base times height because it's a triangle. So here we got 1/2 of the base, which is 1 because it goes from 4 to 5, and the height, which is 20 times 10 to the 2 again, which gives us, what, 10 times 10 to the 2, or 1.0 times 10 to the 3 Newton seconds. So we add those up. What do we end up getting? 4 plus 1 is 5.0 times 10 to the 3 Newton seconds. And I hope that option is there. Sure enough, 5.0 times 10 to the 3 kilograms meters per second. But we know a kilogram meters per second is the same thing as a Newton seconds, right? All right, is there any more? There is. By the way, we're not asked this in this question, but if we were asked to find, let's say, the change in velocity, what would we do? If we were asked to solve for the change in velocity of the object in this graph. We got area, which means we've got impulse. We can, if we need to, set that impulse equal to m times delta v. So we just solve for the impulse. We'd have to be given the mass, which we're not in this question, but we'd have to be given that, and just turn around and solve for delta v there. All right, use the following information to answer the next question. Group of students performs an experiment to explore non-uniformly accelerated motion in which the magnitude of the force applied to a low-friction laboratory cart increases as a function of time. So force is getting bigger. The mass of the low-friction cart is 0.5 kilograms. And we got a graph here, force as a function of time. It's a pretty standard graph here. Although we do have to watch out for this, 10 to the negative 1 seconds, and the time here is 10 to the negative 1 seconds as well. I would also watch out for this, the fact that this doesn't intersect the 0, 0 point, right? The origin, because we tend to make a mistake with that sometimes when it's so close. Area equals impulse, right? We know this. That's what we do. Area equals impulse. Based on the graph above, if the low friction laboratory cart starts from rest, what's the final speed of the laboratory cart at the end of 8 times 10 to the negative 1 seconds. In other words, at the end of the graph, what's the, what did it say? What's the final speed? Let's get the area equals the impulse, because that's what we do first, if we can. The area equals, it's a triangle, so we're going to say 1/2 base times height. It's going to be 1/2 of, what's the base here? 8 from, looks like 0.2, 0.4, 0.6, 0.8, 0.4. So it looks like the base is 7.6 times 10 to the negative 1. How many people got that? 7.6 times 10 to the minus 1? What'd you get? 7.5? Should it be 7.5? It looks like here it's on your paper when you guys saw that, or sorry, on online, was it more clear than this? Is it right in the middle? Okay, so we'll say it is then. We'll say it is 0.5. You can rest assured that on a test or an exam, that would be very clear where that was, right? We wouldn't have to worry about ambiguity like that. Okay, we'll say that's 7.5 then. I'll trust you on that. Times it by the height. The height is, I think that is clearly going to here, which is 3.1234. It's funny, the y-axis goes up by 0.1. The x-axis goes up by 0.2. So we got to be careful of that as well. Right, 3.4 times 10 to the minus 1. So we calculate that. 0.5 times 7.5 times 10 to the minus 1 times 3.4 times 10 to the minus 1. How many people got for an impulse or an area of 0.1275? Yes? 0.1275, that would be Newton seconds, or the other set of units we could use, as they used in the last question, was kilograms meters per second, right? Okay, now when we want to find the change in velocity, we know we're going to do impulse equals m times delta v, or the final velocity, I guess. Delta v is equal to delta p over m. I just found the impulse, 0.1275 Newton seconds. And I'll have to have the mass here. I think it was 0.5 kilograms, didn't it say? 0.500 kilograms. We divide those two numbers, and I end up getting 0.255. Now, really, that's the change in velocity, not the final. But if the initial was 0 and it changes by 0.255, then what's the final? 0.255. It's the same thing, right? If the initial is 0. Now, pay attention here to the way that they express this. We haven't had very many of these numeric response questions thus far that have had a notation like this. We will, by the end of the year, see tons of them, but haven't been very many so far. We have to express this in scientific notation, a decimal b times 10 to the negative c. So let's put it in scientific notation first. This would be 2.55 times 10 to the negative 1. Does that make sense? A, B, C, right? A decimal B times 10 to the C. But you got to be careful here. If I round that to 2 digits, what's B become? Yeah, it was 2.55. If you look at the digit right after that, it's a 5, so it rounds up. Becomes 2.6 times 10 to the minus 1. We'd record that as 261. So on your test bubble sheet, it would look like this. You would fill it in as 261. Always start on the left-hand side. If you got a blank box, leave the blank box as the last one. Okay, that first box will never be blank. So don't get mixed up and say, oh, blank 261. It's first one is never blank. The second one will never be blank. The fourth one will sometimes. Occasionally, even the third one will. But usually they're all filled up. If anything's blank, it's going to be the last one or the third one. Or the third one. Okay? Good there? Okay, we'll check over practice question set number 4, as I say, tomorrow. We'll do a quiz on impulse graphs or force versus time graphs tomorrow as well. And then, of course, have quiz number 4. We'll have that on Monday.